Hi everyone, and welcome to this video where we will be exploring intersecting planes as part of the Leaving Cert DCG course. Thanks for watching this video. I hope that through interacting with this model we have here in front of us and seeing the drawing sheet that I have prepared and ready to draw through, you might get a greater understanding into intersecting planes, lines of intersection, and dihedral angle between two intersecting planes. First of all, the two planes that we have in front of us are defined by 3 points, and these 3 points, let's say the tree here in red and then the tree also here in green, number 1 there, 2 and 3. The points on those planes are quite often found using coordinates, so coordinate geometry, given the x, y and z coordinates of the 3 points. We plot out our points in the elevation view on the vertical plane and down the plan view, and that is just here, elevation of the red, elevation of the green, and then the plan of the red and the green down there. And the challenge for us is quite often to try and find, first of all, find the exact profile of intersection of the two planes. So where exactly does a plane enter and exit? And then after that, it will be to find what's called the dihedral angle. So find a view where you can see both planes as edges. If I turn it up this way, it might look a bit more clear. Find a view where both planes appear as single line or as edge views, just like that. And then that will result in us being able to measure the true angle that lies between both planes here, which is called the dihedral angle. So that's the purpose of the question, is being able to manipulate these planes and first of all figure out what it looks like where they intersect each other, and then second of all figure out the exact angle at which they are intersecting each other, the dihedral angle, the angle between the planes. So that's the purpose of this video, and I have my SolidWorks model here to flick through, and then I also have the full drawing on paper with the coordinates of 6 points, so that you can go ahead and draw this at home as well. The purpose, or the principle here really is this: if we can cut the object and find out what's happening in two locations, then we can solve the initial part of this question. So the initial part is find the line of intersection between the two planes. If we can cut the object, and the easiest way to cut this object is with a horizontal cut, so parallel to the ground there. And if I can cut the object now, as we can see here, I'm bringing up my horizontal plane and I am sectioning through the red and green plane right now, but my sections aren't actually crossing. Now that is still useful. It really is still useful, but I'm going to just keep going up now a little bit further until I can get more information. And there, where are we? There now, that is the first point that I'd like to see. That is the point where this edge of the red plane breaks through the surface of the green plane. That is the start of the line of intersection right there. And as I move my plane up along, I can see that the line of intersection, it lies on the point here. So any place that I stop along the way, I have a horizontal section plane that cuts through my green plane, cuts through my red plane, and where the two cuts cross, let's just say there, where the two cuts cross right there, gives me a point on the line of intersection. Okay, so by sectioning the planes, let's just say once up here and giving a point on the line of intersection, and once down here and giving me a point on the line of intersection, I can, if I have 2 points, I can draw a line. So that's just the background information that we need for this and the background knowledge. I'm going to just turn off, I'm going to turn on my first horizontal plane right there. So I've picked a position and I have dropped in a horizontal section plane. So I just picked a random position, and I'll have a quick chat on when we're on paper about how to pick those positions and hopefully always get the result you want. But I've picked a position and I've dropped it on a horizontal plane. If we just look in at the elevation there, that's the position I've picked. With that horizontal plane, I want to do this, okay? I want to section with that plane. So I'll just take that off. So I've just put a section through with that plane that I dropped in. Let's look back at the elevation again. So we can see that everything from there up has disappeared. Apart from my elevation sketches, the sections don't cut through sketches, but it's a horizontal section through at any random height you want, any random position. Once we turn on section view here in SolidWorks, it removes the fact that I had these set as a glass material, and it shows up the line of intersection straight away. We can see that that is the line of intersection, and we can see that it lands on that point. So where my horizontal plane went in, and I've just set a section view, I get the cut on the, that's the red one, isn't it? Yeah, I get a cut along the red surface, and I get a cut along the green surface. So where are they? That's the cut that goes along the red surface right there. That's the cut that's along the green surface right there. And that gives us a point of intersection right here. To turn off the section view again, so there's my plane. My plane is in there. And the red and green lines show where my plane sections and cuts the two given planes. So my horizontal section plane is cutting the two. What does that look like in my views? Well, first of all, anyway, it just looks like a blue line there because that's the plane. That's it. And then what does it look like in plan? Well, there's going to be a red cut and a green cut. So there's the red cut. Okay, so it's this line right here as projected down to plan. And then there is the green cut here. And as we can see, that gives us a point on the line of intersection. That right there is a point on the line of intersection. If we have one plane done, we need to do a second one. We need to drop in the second horizontal section plane. So there we are. That one dropped in as well, a horizontal section plane number 2. And if I look in at the elevation, just to get an idea of the position of this, there we see it. So I've just 2 section planes. Now, the way we can, and I'll look at this a bit more in detail now on paper, but you know, we're not going to take a section plane through right up here at the top because that's useless, because there's only one plane to cut. We need to take a section plane in a position that it cuts both planes. And from a bit of experience working with these, then you start to realize that, first of all, if you put the two of them too close to each other in the center, you'll probably lose a lot of accuracy. If you put one away too high up, you probably won't be cutting on the line of intersection. So really, it's practice. You'll start to get used to it, and you'll practice away until you you'll be able to visualize the two planes and see a good position to put your section planes. Anyway, that's off the point a little bit. I want to see what my section looks like on this plane right here. So let's just go back to that one. We'll repeat the process really. I'm going to pick the plane there. I'll add a section view in with that plane. And there we go. I'm sectioning both given planes. The green one I'm sectioning along here. And the red one I'm sectioning along here. And when I section them, I get there's my red profile. I darken my colors this time just to differentiate them from the ones above. There's my red profile and there's my green profile, and again they cross each other on the line of intersection. So if we can think back to what we had above, we had our red and green cuts. There's the red, there's the green crossing on the line of intersection, and we have our red and green cuts crossing on the line of intersection again. So that is going to be enough. 2 points can define a line. But we're not quite finished yet. So there's my 2 section planes, cutting both above and cutting both down below. Let's show it in the elevation now here first. So there we are. I just lightened off the color again. So there's my very, very light blue, I think, section plane right there, my horizontal section plane 2. And the 2 cuts that it gives us then have to be shown here. So this dark red and dark green need to be shown here down in plan. So there's the dark red cut. There's the dark green cut. Now, what are we looking at? We are looking at that, up here. That is a portion of the line of intersection. Is it the full line of intersection? No. And the reason it's not is, unless I was very lucky and I started my first horizontal and second horizontal in the exact correct positions. But that right now, because the horizontal sections were just basically at a guessed position and we just dropped them in someplace random, we probably have not found the exact end of the line of intersection. The end of the line of intersection has to hit the first edge, is the way I define that. So you extend your line of intersection out until it hits an edge. And now you don't extend it out to this edge, They can't be intersecting out here because there is only one plane. So you extend it out to hit the first edge. There. You extend it up to hit the first edge. There. So that's just how you finish it. So extending it up and down to hit the first edge. What else do we need? We need that same line of intersection here, down in plan. So it's extended out. It's the black line that goes through the intersection here of the light red and green, the intersection here of the dark red and green, and it's the black line then that crosses through and hit the first edge. It can't go all the way out here. There are no two planes out there to intersect, and the same principle applies here. You can only have a line of intersection in a location where there are two planes. Now, the last thing then to do was actually just draw that in the elevation as well, and I'll kind of go through that. That'll make more sense on paper when we get to that stage, but that would have been drawn in plan first and then projected from a point on the red line, let's just call it A to B, and we'll project it up onto the line A, B, and then you'd have a point on the red line B, C, projected up from plan. Now, that is the first part of the problem here, and it's actually just finding the line of intersection between the two planes. After that, we're going to be moving on, and we're going to be projecting some extra views here. I'll actually leave that part for now. I'm going to go on to paper now for a while at my worksheet. I have this question already set up and ready to go, and we'll have a closer look and just see. This is all it in 3D, and hopefully it all makes sense. Now we'll see what it looks like on paper in 2D when we're linking up our plan and elevation and linking up all points. So for now, we're back to paper. We are on paper with our intersecting planes question. I've already set up and ready to go here. So the coordinates of the points, first of all, if anyone wants to just draw through this one at home. The two intersecting planes are defined by the points ABC and DEF. A is 130, 60, 5. B is 210, 10, 90. C is 200, 80, 25. D is 240, 20, 30. E is 155, 85 and 5, and F is 130, 45 and 60. Now, to ensure that I get a good fit for this on my A3 page, I think I reduced all of my in measurements, and what did I do? Yeah, I just subtracted 50 millimeters off all of my in measurements, my X measurements there. I was hoping it would all fit here on my A3 page, so I can take 50 mil off all of my ins and it'll work just fine. Just instead of having it right in along to the center of my page, I've allowed a little bit of extra space there for the upcoming drawing and all the views that have to go with this. I've drawn my planes and I've just lightly joined them together because I don't really know yet what is and is not going to be heavy. The only line that I could draw in heavy here was in plan D to E, because there is no second plane out there. It's a completely unobstructed line, so I dropped that in heavy. Okay, what I'm going to do is this stuff. I'm going to go with I'll go with two of the colours that I had there on the SolidWorks area, and I'm going to just add a light little bit of colour just around the corners, because I'd like to be able to start visualising what I'm looking at here. I don't just want to be seeing two triangles, I want to be seeing two surfaces. Okay, so I want to be able to see my two planes clearly and define between them. So a little bit of colour, I think in a way for these practice drawings, a little bit of colour will always help you with starting to visualise solutions and visualise what we're supposed to be doing here. So that is the area of the red that I know I can see. I don't know where they're intersecting, so I don't know how far in the red goes. I might just pause the video and add a little bit more colour to the outside corners of the red and plan and the green. Now that's as much as I can do at the moment, because I don't actually know where the line of intersection is, or I'm not quite sure what's cut and what's not, so, or what's on top and what's below. So that's, I have to leave it at that. I can just do the kind of the extremities of the objects. So that's the whole thing set up. What I'm going to do next is I'm going to just give a go at picking the points, picking positions for my section planes, my horizontal section planes. Now what I was talking about there in the video is this, okay? If I've been picking points here for my section planes, there's no point in picking anything down here because the two objects are not crossing at all. There's only one object, there's only one plane up as far as here. So I'm definitely not going to pick a point where there's only one plane because I'm not sectioning the second plane. I can't see the point of intersection. So if I move right up along, you know, I'll start at the top and work down. Anything from point E there, that's only one plane, down to point C. Right here, the two planes are separate. It still can work, but I'm going to try and make things a bit easier for myself. I'm going to go right down and I'm going to start off with my first section, and I'll drop it in there in blue. My first section I'm going to have going through point A. Yeah, that's horizontal section 1. H section 1. Okay, so horizontal section 1 going through point A there, and I assume and I think that the two of them will be crossing at that point, and if they're not, that's okay. We can work with that. And I'm going to have horizontal section 2 then. I'm going to drop. I was going to use point F maybe, or I might drop down just that little bit lower because I just want to show you don't have to use a point on the drawing. It's already given. So I'm going to use that one there. So that's H section 2. H. Horizontal section 1, horizontal section 2. Now, I need to draw what those horizontal sections look like in plan. Now, it's just so amazing that even I'm going to really take my time on this one because I don't want to make a mistake here in the video, and it's such a simple process, and it's the amount of people that make mistakes at this stage is just it's a pity really, and I think it's the color here that should help us to ensure that we don't make the mistakes. If we just work on horizontal section 1 at the moment, the blue one, I am going to have 2 cut lines. One single section cuts 2 planes, so I should have a red cut and a green cut. The colour is what really is key here. It just makes this so much easier to get it right. My green cut goes from point A to point 1. Point 1 is on the line BC. 1 on the line BC. There. That's point 1 on the line BC. And that, where is it? That's point 1 is on the line BC, and that is from A to 1 is the green cut. So A to 1 is the green cut. A to 1 is the green cut. Horizontal section plane 1, again, it cuts the red plane from point 2 to point 3. I need to find those 2 points. Point 2 is on the line EF. Point 2 on the line EF. And even though you can't do this in the exam, I really do talk my way through these, because even if I was doing a question like this myself, I would talk my way through it, and I'd say point 3 is on the line DE, point 3 on the line DE. So that I wouldn't do something like this, I need point 3 to be on the line DE, which is here. That's point 3. I don't want to drop it onto the line, what's that one, AC. I don't want to drop it onto the line DF. I don't want to drop it on the line AB. There's just so many ways that it can go wrong if you're not quite concentrating, and I think that if you have the colour in there, it really helps, because I know that that cut, point 3 cut on the line DE, has to be on a red line DE. So it just, for me, it just makes the whole thing a lot safer, a lot less chances of an error. So there's the red cut right there, and I'll just add a little bit of it. There we go. And where those 2 cuts cross each other, give us a point on the line of intersection right there. That's horizontal section 1. And horizontal section 1 has just given me a point on the line of intersection. I still have no idea where the line of intersection is until I go ahead and do horizontal section plane 2. Section plane 2. I started with the green and then I went red last time. I'm going to do the same this time, okay? What numbers have I used? I've used 1, 2 and 3. So that's going to be point number 4 on the green plane to point number 5 on the green plane. So point number 4 is on the line AB. And where is AB? It's this long one down here. So point number 4 is on the line AB. That's number 4. Point number 5 is on the line BC. Point number 5 on the line BC. Okay, that's 5. So 4 to 5 is the resulting cut from section plane 2. Now, of course, my lines I'm just drawing there is just to aid the understanding. They're not hidden lines or anything. It's just a little bit of understanding, but I don't want big solid green lines there really. So that's 4 to 5. And then finally, point 6 to 7 is the cut on the red plane. 6 lies on DF, and DF is this bottom one. So 6.6 lies on the line DF, which is down here, number 6. 0.7 lies on the line DE, 7 on the line DE. 7. And there we go. So we'll draw the cut, the resulting cut 6, 7. And that section crosses here. So from my 2 sections I have 4 cuts. From my 4 cuts I have 2 crossing points. I'm going to draw a line joining my crossing points. Now try to be as accurate as you can here. Join your crossing points and extend until you hit the first edge. First edge you hit is the key. That's right there. That's right there. And there's the line of intersection. So extend from your crossing point to your crossing point, join them and extend to hit the first edge, which in this case is the green one right here. And that gives you your full line of intersection. We're not quite out of the woods yet with this one though, even with the elevation and plan, because I don't have a line of intersection in the elevation and I need it now. So 2 more numbers left. What have I used? 6, 7. The line of intersection goes from point, I'm going to call it 8 there to 9 there. 8 lies for me on the red plane on DF. Okay, so point 8 is on the line DF. DF is this long baseline down here. Point 8 on the line DF. There. That is point 8. Point 9 lies on the line AC. AC is this green line up at the top. Point 9 on the line AC. Okay. So 8 to 9 there. Is my line of intersection. That is the line of intersection found. Now the next thing to try and figure out is this. What object is in front and what object is behind? And basically, how do I add the colour here? How do I make sure I get my colour correct? Because I think it's when the colour goes in that the understanding comes with it. Now what I'd be looking at is this. To understand the colour, really, it's a visualization thing, and sometimes we'll get it wrong. Will it change the question? Will an examiner look at it and say, no, they added a bit of wrong colour there on this plane? No, absolutely not. Technically, right now, my question is correct. So far, I have full marks. For my own sake and visualizing this going forward, I like to just get the colour in on the planes, see which plane is in front and which plane is behind, and so on. what I do is I start off in the plan and I say, right, what point is out here at the front, out near me, and that for me is the green point B right here. And we're thinking the B and C there is right up in the air, and they're both out towards me, towards the front. So for my bit of visualizing in this one, I think that this green is going to be the prominent colour right in as far as the line of intersection. So I'm going to add the green colour right up along the line of intersection here. Up to that edge. And very importantly here, I'm going to be able to do a little bit of heavying in now as well. I know that this edge right here is fully visible. I know that this edge along here stops, restarts out there. This edge down along here hits the green and goes solid again from the line of intersection out. So we start, I think already it starts to come together and make a little bit more sense. The red goes as far as there and is overshadowed by the green. And that's no small task sometimes, to be able to visualize these, and you know what, it can go wrong, and I'd be doing them sometimes and I might actually realize that I visualized it the wrong way, maybe assumed that the point was in front and the point behind. But look, we give it our best shot, and it's just the more you practice, the better you get at visualizing the likes of these questions. There we are, there's the two planes as they intersect each other, and it just straight away for me it just makes so much more sense. We could add this in as hidden detail if we want, and if we want to say that one plane is behind the other, we could add it in as just a slightly lighter line if we want, and that would be kind of assuming that the two objects are glass like you would there in SolidWorks. But there we go, that's the two planes right there. And now I'd like to add the colour into the elevation. Of course, here in the elevation we're going to look at this. Okay, we're going to have a look at what point is out near us, I suppose. Point B being out close to us and point C being up high. They seem to have much more prominence out towards the front over this red plane here, and we can imagine if we were looking in at the object that this area here would be kind of striking us first, not the red plane, so that takes precedence over the red plane there. And if it does, well, it has to go straight in there as far as the line of intersection, and it stops that. And the colours always change at the line of intersection, so we go right in here to this corner. And we, as I said, we have a colour change at the line of intersection. It has to be because the green is sticking through the red plane at that point and pressing out the back. So the red plane has to take prominence. And if it is, and if all this is red, then it means that this little portion here that's kind of out on its own will have to be green. And or red for the rest. Now, let's not forget the little ends that are sticking out there. And finally, just to, I suppose, make it easier going forward and just to define it a little bit better, I should go over my lines now, what's heavy and what's not. And I do like to put them in as hidden, even though it's not necessary. And we get all edges redefined here for what's solid and what's not. we go. That is my two planes finished. It is all of the points of intersection I need done right there. What I'd like to do at this stage is just as a tiny little extra, and you know, I don't want to confuse anyone with this, but I do want to kind of just deal with it just in case it did happen. If you picked a position that was too low, what do I mean by that? We have done horizontal section 1, horizontal section 2. We have the line of intersection in both views. It's perfect. But let's just say you weren't quite as lucky, or maybe you're not as good at visualizing these yet, and you picked that one right there. That's a very poor line. Now let's go once more. You picked that one right there. You picked, and I put this in brackets, that as your H section. Number 2. If you did, would it work? That's the big question here. Would that actually give you anything? Since we have now gone ahead and we know that that is the line of intersection, and that this does not reveal a cut or does not reveal a point on the line of intersection, would it work for us? And the answer is yes. Yes, it would. This is why it would work, okay? And once again, just to reiterate this is not necessary at this stage. I'm just taking a slight little sidestep here and just working on something just to solve a little problem before the problem ever happens. Or maybe you've encountered this problem. If you pick a section and you realize it's not working, well, you could just go and move your section, or you can make it work. This is how we'd make it work, okay? I'm going to go for what numbers? I've gone as far as 8 and 9. So I'm going to cut the green plane from point 10 to point 11 right there. Point 10 is on the line AB. 10 on the line AB. 11 is on the line BC there. 11 on the line BC. 10 and 11. This time, that's what we get. Okay, so there's 10 to 11. Using section plane 3, that's one of the cuts we get. And it cuts the red plane from point 12 to point 13. 12 is on the line DF. 12 is on the line DF. 12. 13 is on the line ED, this top line here. 13 on the line ED. 13. There's 12 and 13. Now, one thing to note is, as you might have just realised, every horizontal section, the blue, the orange and the pink one, give us a parallel line on every plane. And that would be parallel to the trace of that plane if we brought it down to be parallel to the horizontal trace. So just something to note there. If we look at the cuts on the red plane, for example, the blue one is here, the orange one is here, and the pink one is here, all parallel cuts. If we look at the cuts through the green plane, we have the first one here, we have the second one, and the third one, again, all parallel cuts. But the previous two cuts gave us something immediate. It gave us a crossing point, and it gave us a second crossing point. But this time it doesn't give us a crossing point. We have our red cut there, 12 to 13. We have our green cut, 11 to 12. Now, does it matter that it doesn't give us a crossing point? No. If it doesn't give us a crossing point, what we can do is we can take the question and enlarge it. We can act like as if the question is bigger than it is by doing this. Very, very simply. Take the line 12 to 13 and extend. Take the line 11 to 12, or sorry, 11 to 10 and extend. And you might have to zoom in to see this. Where they extend, give me a point right there. And what you might see is that that point lies perfectly in line with the line of intersection. So if I happen to pick an area that is too low, i.e. below the line of intersection, or if I picked one that's too high and above the line of intersection, you draw your resulting cuts and you extend your cuts through, And what you've basically done is you've said, right, it doesn't work on this size of a question. I'm going to make the question much bigger. I'm going to extend on this red plane until it's that big. I'm going to extend on the green plane, and you get a point that would be on the line of intersection. You join it up to your second point that you had already found earlier, and you just cut it off at the inside edge. So that you always work with your line of intersection, start in the center and work out to hit the first edge, out to hit the first edge. And that's it. So that's just a side note there if you took a section plane too low or too high. But it works. For now, let's go back to SolidWorks. Let's look at the next stage in this, and that is your line of intersection and using it to find a dihedral angle. Now that we have found the line of intersection there on our drawing sheet, it's time to go for our dihedral angle, and what we're looking for is this. There is the line of intersection right there in the center. I want to find a view that shows the line of intersection as a point. And when I see it as a point, as we can see here, when the line becomes a point, each plane becomes an edge view. If I get an edge view of each plane, I get the true angle between the planes, and I can measure either one. That is my dihedral angle. I'm going to do a little bit of hiding here just to simplify this just that little bit. I'll hide all these labels as well. Sorry, now, just to get these, oh, that's going to cause a bit of a problem. We get them out of the way now. Hopefully, if they'll do it for me. No, they'll be okay for now, I suppose. Where is it? Label 2 hidden and label 1 hidden. Okay, so at least we get a little bit out of the way there. What we're looking for next, and again, I might just hide these sketches as well, and I'll just be left with my line of intersection there. So I have the line of intersection between the two planes. I have the full plan and the full elevation shown, but that's okay. We'll work with that much now. That's loads there. So this is a different question, obviously, with different coordinates, but the principle is the very same. I have my line of intersection, and I want to find a view showing that line of intersection as a point view. If a line lies on a plane, and if we see a point view of the line, we see an edge view of the plane. Well, this line lies on both planes. So when we get a point view of the line, we get an edge view of both planes. That's the principle here. To find the point view of a line, you have to look along a true length. To find the true length, you have to look at 90 degrees to a line. So, taking it from there, I need an auxiliary view looking at 90 degrees to my line. Where is the line? Well, I actually just do a little bit more hiding here now. If I can just hide off my sections just to simplify this thing a little bit. That's my line of intersection right there. Okay, I'm looking at 90 degrees, so perpendicular to the line of intersection. I'm looking out along, and I picked the point and stopped and dropped my x1, y1, and from there I'm putting in an auxiliary vertical plane. So I'm projecting out at 90 degrees to that line. What does that give me? That gives me, once I take all of the points for both planes and I'm projecting from the plan, so this is an elevation. Because it's an elevation, we're going to rise up the lines and take all of the heights from the main elevation. So heights up to points A, B, and C for the red plane, and then D, E, and F for the green plane, or whatever way my colors were on paper there. But there's my two planes, and then of course I'm also going to take, really importantly, is to take the two ends of the line of intersection and take them from plan. Of course, I've just shown it here in the 3D. Take the two ends of the line of intersection and just take that over as well. And that means that we get this. We get a really important true length of the line of intersection, and we have both planes with us. So we have a view, an auxiliary view showing the two planes and showing a true length of the line of intersection. Now, here's the thing. This directs me for the next step. Okay, if I just select that line for a second, and if I just turn this around until that line now over here is going to become a point view, just watch this. Once that line becomes a point view, there, my two planes have become edge views as well. Or I'm thereabouts. I'm just a little bit off on that one. Once that line on the auxiliary becomes a point view, my two planes have become edge views. So that is what's directing my next auxiliary. So I have a true length. If you look along a true length, you get a point view. So let's just do that much. We look along the true length. Okay, so there, the first auxiliary here shows the true length of the line of intersection. That's my little note on this one. I'm looking up along that true length line. I'm picking a point and I'm stopping and drawing my x2, y2. I'm dropping in my plane. And then I'm projecting everything up to that plane. So there's nothing majorly difficult about it here. I think at this stage, if you can do two auxiliaries, you can solve this question. Projecting everything from my auxiliary view up. And don't forget, what do we always say about finding a view up here? You skip this view and you take your distances back to the plan. And I think it's fairly obvious here when you look at this why that is the case. The distances from the x1, y1 back to the plan have to be the same as the distance from the x2, y2 out to the plan. So that's why we want to reference back from here as an exact link was out from here. Once I do that, I get the red plane as a line. Okay, we get the 3 points on this model here. We have 1 point on the end, we have 1 point here, and we have 1 point here, and they all end up perfectly in line, especially if your work is accurate on paper. We have the second plane, the green one there. As you can see, we have 1 point in the plane, second point, and third point down low here. And let's just turn this view around to see if it makes sense, and it certainly does. You know, it shows the two planes appearing as two edge views. And finally, I can just take note of my dihedral angle, or DA, 95 degrees. Now, if it says determine the dihedral angle, you have determined it literally by getting here and just maybe put a little arrow. Determine and indicate is just measure it. Now, I would always suggest to students to just measure the angle and take note of it anyway. There's no marks lost for taking note of the angle and dropping it in there. So measure that angle and drop it in there. And you could measure either the larger angle right here or this smaller angle here. It doesn't really matter. Either one will do. And just the last note then I have just left there is that the second auxiliary showing the point view of the line of intersection. So first auxiliary view here shows the true length of the line of intersection. So we have a line of intersection found. We look at 90 degrees to the line of intersection for our first auxiliary to get a true length, TL, true length of line of intersection. And then we look up along that true length. And in our next auxiliary we get a point view of the line of intersection, which gives us our dihedral angle. Let's see how all of that ties in now and how it translates back onto the page. And that is the foundation knowledge that we need to solve the rest of this question. So let's go on that one. Now that we've seen all of that on SolidWorks, let's get drawing, okay? The first job I'm going to do, obviously it's a different question. Last time the line of intersection, there the one in SolidWorks, well, the line of intersection was facing a completely different direction. But it doesn't matter. We'll work with what we have here. Right here we have our line of intersection. I'm going to set my adjustable, and really we need to just be as careful as possible in the setting, even for this first angle here, because it's going to determine how accurate we are when we go forward to our next view. So set that as accurately as possible. This is where fine liners become a problem, because it's so hard to get an exact match of an angle. But anyway, we'll go with it. So I have set in line with the line of intersection. I'm now going to view normal 2. So I'm going to project all of my points, starting here with point A, and project them out. Moving on to E. Point 9, I'll just leave it out there someplace. I'm not going to take that with my compass. Point F in here might need to be extended on. And point B there, I'm going to have to use some sliding set squares here for this, so I'll set my angle and hold it. And I'll slide it down with my 45 here. So there we go. That is all of my points projected. I might need to extend point F out. I'm not quite sure actually with that one. Might need to take point F out a little bit further there. Now, I should have done this before, but I just spotted it now. This XY line there is kind of annoying me a little bit. I might just juice it into that a lot. And drop in this projection again. I'm going to put in a line parallel to the line of intersection, and that's my X1, Y1 line. There's my X1, Y1 line right there. Now, time to take my compass. I'll start off with the green plane. I'll take the height of point B from my elevation. I'll go down to point B and up to the X1, Y1, and that is point B right there. And label as you go. I'll take the height of point A from my elevation. From point A, mark it up. And I'll take the height of point C from my elevation. Where C is there. C. You can draw the plane now if you want, or you can take the rest of the points. I like to just, sometimes I'll just draw them in as I go. And I'll drop them all in light at the moment. A, C. There we are. That's the ABC plane, the green one. In the red one, start off here with point D. Take the height from D, from the X1, Y1 up. It's point D. Point F is my next one. F. Point E up at the top. And we might as well just drop in that plane as well. Then the line of intersection. Now I can see a little bit of an issue about to crop up here. Projecting point 8 over here onto the line DF is going to be very, very hard to keep accurate. So I'm going to just kind of safeguard myself in a second way there. I'll show that in a second. Projecting point 9 mightn't be too bad. Point 9, the end of the line of intersection, is on the line, what is it? CA. So AC gives me 0.9. So whereas AC gives me 0.9, which is there. 0.9. That should be accurate, but I want to check it just in case it's not. Okay, and the way I'll check it is like this. I'm going to take the height of 0.9 from the elevation, and I'm going to just ensure that it is the exact same over in my auxiliary, and it is pretty close actually. Yeah, that's very, very close. I'm happy with that. 0.8 could be a problem though. I can anticipate this problem because of how close, when projected, D and F are so close to each other that 0.8 is going to be really, really hard to keep it accurate. So what I'll do is this, and again I'll project 0.8, but I'll also take the height of 0.8 and just, again, I just don't want to get to my next view and realise that it's off by a lot. So DF is there, and that's not bad at all. That's very, very close actually. So we'll certainly take that. There's DF. That is TL of LO by true length of the line of intersection right there. Now, I'd like to add some colour into this view again. And when adding the colour over here, what we're looking at is this. I think that the colour is such a challenge here. It really makes you challenge your visualization When we view from this angle right here, looking in to see this auxiliary view, seeing the true length of the line of intersection, the green plane is the obvious big one. Okay, so right down here to B down the corner is all green. So that's going to be all green right up along there. Right up along to C is green, of course. So all of that. Green is really the big prominent plane in this view that can be seen. The red one appears very small in this view. And this guy here being green as well. But what else though? Where is the red? Does the green go in on this side, or does the green go in on this side? And what we're looking at is, as we look at the red one, is point D or is point F the one that's out close to us from our viewing direction? And from our viewing direction here, it's quite obvious that F is the one that's out really, really close to us. So F has to be in our vision. So if I just start with F right there, it has to be in our vision. So right up to the line of intersection like that, and up through the plane on its way up here towards, what's that, E, isn't it? And up, right up to the corner will be right there, of course. That's a singular plane there, and that's it, apart from this little extra area here that's out on its own. So that's just a little bit more visualization, I suppose, there, and it's a little bit of a challenge for you to kind of see what's happening. We really find that it's so helpful, and it's a great way when you're going forward with these drawings to challenge yourself. So there we go. There's a little bit of colour added to this. Now once again, just to really reiterate this in case anyone thinks that you don't have to add colour in the exam. You can go ahead without it, and it's just for practice. I like to add in the colour, and I think it just helps with seeing the solution and seeing the principles in action. And there we go. I'm going to do just like I did on my previous views, and I'm going to heavy in what should be heavy here. There we go. So from that view we can clearly see where the line of intersection is and which plane is in front, which is behind. Let's set up for our final view here. I'm going to set my adjustable. I'm going to line up perfectly with the true length of the line of intersection right here. I'm going to take that as my projection angle, and I'm going to project all points up to my next view. There's the 3 points on the green plane, and then there's E, there's D, which I'll extend there again, and there's F, which I'll extend. And as I showed in SolidWorks, once our x2, y2 is in, and I'll drop that around there. There's my x2, y2 for my next auxiliary. Where do I get my distances from? Well, that's a plan, that's an elevation, and that's a plan. So we skip one view and work back. Now I'm wondering here, will it all fit on the page? And if it doesn't, I can work with that too. And I don't think that's going to fit on the page here. No, I'm just gone a little bit off. So what I might just do is I might shorten up my drawing a little bit. And I'll do that using this method here. I'll take the distances from my x1, y1 back to the plan, and I will shorten them all by the same amount, and I'll do that by putting in a reference line. And my reference line is, just check that I moved that there. I'm going to take it to the first point I hit, which is point D. And there we go, that's my reference line, REF line. That reference line just means that I have subtracted a certain distance from everything. So I've subtracted about 40 millimeters from all of these. So now it should easily fit on my page. Really handy to keep your drawings tidy and neat and keep them compact. First off, I would usually be going back my 40 mil back to D as my first and closest point, but this time D is on a 0. So D is there. That's point D. I'll do the 3 points on the red plane first. I'm going to go back to point E. And I'm going to go up from point, that's E, isn't it? Yeah, up from point E on the X and Y went there. And finally, the distance for the red one up to point F. Up to F. D, E, F. You can draw the line if you want now, and hopefully they'll all line up perfectly for you. I'm going to take my distance to the closest one on the green, which is C right here. And I'll drop it up from C. I'm going to take my next distance, which is marginally bigger, up to B. Up to B. And finally the largest one for the green, up to A. Right, there we go. What I'd like to do here is just have a quick look then at how accurate it all happens to be, and if it's that's pretty good now. To be fair, that's not bad at all. They're falling pretty much perfectly in line there. So if you're lucky enough or well practiced enough that happens, then it's great. If not, you need to just really work on your accuracy, because if you're finding that you're drawing these views and that there's 3 and 4 millimeters in it and your points are all way above or way below, then you need to really just work on your accuracy, and every single thing right back to the accuracy of your section cuts and your resulting cuts on the views here, and your linking of your points together for your line of intersection. Everything counts when it comes to your accuracy. That D, E and F is the red plane, so I'm going to take that as the edge view of the red surface right there. And then A, B, C, how straight is that? That is pretty good as well. So A down through B and then hitting onto C right there. It's not 100% perfect, but it's quite close. I'll take it. A, B and C right there. That gives me an edge view of each plane. Now, what else should I do? If I can find the protractor. Here, I'm going to drop in my protractor, and I just always have the habit of maybe just dropping some form of an arc there. This lines up, and we bring that angle to me. It looks like, and please don't make the simple mistake here of reading up from the wrong side. It reads around from the first line all the way around to 136 degrees. So D, A, 136 degrees. So there we go. I'm going to pause the video. I'm going to add just a little bit of colour here and there and a few more notes possibly, and then that'll be it for this one. So just go ahead, get it finished, pause the video and zoom in on sections if you need to, and I'm going to just add a little bit of colour here and there. And there we are, there's the finished questions showing our elevation on the vertical plane. We have the plan down here on the horizontal plane. We have our AVP, auxiliary vertical plane, and we have a second auxiliary plane then. It's not an auxiliary horizontal plane. That would often be mistaken there. It's actually not an auxiliary horizontal. This is an auxiliary vertical, because what you could do right now, but ideally we wouldn't have reduced our sizes here, but what you could do right now is you could cut around the outline of this, just like I would have done back in first year with students. I'd have cut around the outline of these planes and fold them up, but you could easily cut around the outline of the planes right now and fold along each of your XY, X1, and X2, Y2 lines and see the whole thing coming together like it was in SolidWorks. But this is not an auxiliary horizontal plane, it's just a second auxiliary plane. So we have our true length of the line of intersection in here, okay, TL of LOI. We have our viewing direction along the true length, okay, view along TL. Up here, right there in that point in the corner, is point view of line of intersection, which gives us our dihedral angle of 136 is what I got in this case here. So it's the point view of the line of intersection that gives us the dihedral angle. It's looking view perpendicular to line of intersection. So it's a perpendicular view of a line of intersection to find it as a true length. Look along a true length to find it as a point view. And we get an edge view of both planes. So there we have it. Coordinate geometry and dihedral angles between two intersecting planes, all there in the one question. I hope this video was helpful. Please let me know in the comments if there's anything else you'd like to see, and thanks very much for watching.